Hello there. This is David Gordon, the Global Product Manager for Haskell. Very recently, we had our Q Drive webinar, and a number of questions came up. We received several dozen questions. We were only able to answer a few during the webinar itself, and we said we would answer the questions and drop it into our YouTube channel with the answers here. So that's what this is right here. So thank you for viewing this video. Uh, First question is, how is efficiency calculated? Volumetric or what? And there are several types of efficiency associated with the Q drive. There's energy efficiency, which is how much electrical energy is converted to mechanical work in the motor, turning the ball screw, and then in the gas section. This is very high. The motor is up around 95%, and we have almost no loss between the motor itself and the ball screw and the transmission of energy into the gas section to push the pistons. So I would expect to be 94, 95% efficient in how we compress the gas, or the energy for compressing the gas. The other efficiency is the gas compression efficiency. And as was discussed in more detail in the webinar itself, that's very high because of the very low unswept volume of the Q drive. Is supercritical CO2 considered compressible or not? Supercritical CO2 is somewhat compressible, not as compressible as a gas or a vapor, but it's a lot more compressible than a traditional non-compressible media like oil or water. So it is somewhat compressible, but it's somewhere in between. But it's going to be closer in the way it handles. It's only compressible by a factor of maybe 1 or 2 compared to gases, which are substantially compressible, or water, oil, which is almost incompressible. Can the Q drive be configured for classified environments such as Class 1, Div 1, or 2? The current Q drive cannot be configured in operation in hazardous environments nor handling combustible gases. We are developing a Q drive for handling hydrogen. Is N2 or nitrogen a gas that's compatible with the Q drive? Absolutely. We have several Q drives in the field that are very successfully compressing nitrogen. In the example during the webinar, we said there's a gas compression ratio of 36:1. And that was part of we talked about the efficiencies of the Q drive. And I think in the example, we said we had gas at 200 PSI and we wanted to get it to 7,200 PSI. So that meant that we had a total gas compression ratio of 36:1. And I think we need a little bit more explanation here. Because if I have 2 stages, to figure out the theoretical compression ratio across each stage, assuming that they're equal across each stage, you take the square root of the total gas compression ratio. So the total gas compression ratio is 36. So the square root of that is 6. That means that each stage would see an approximate gas compression ratio of 6:1. Now, in real life, it's never going to be that even. You might have 5:1 on the first stage and 7:1 on the second stage or something like that. It's just going to find its point where it works, but you use the square root to calculate the ratio across 2 stages. Now, if there was 3 stages, you'd use the cube root, or if there was 4 stages, you'd use the 4th root of that gas compression ratio to figure out what the compression ratio would be across each individual stage. What are the capacities of the Q drive electric compressor and capability, and are they available? And do you have a presence in India? Since the Q drive is a positive displacement compressor, and we can handle a variety of inlet conditions, the flow is very dependent upon the inlet pressure. Obviously, the more inlet pressure I have, that means the more molecules are being pushed into that compression chamber, so the more gas flow I'm going to have. So it's really hard to answer that question without getting a better handle on what your conditions are. So please reach out to a Haskell salesperson or channel partner, and they can help answer the question for your specific needs. And yes, Haskell does have channel partners and sales managers in India to support Q drive or any Haskell products in that area. What are the advantages of the Q drive versus other motor-driven compressors? I think the webinar answered this pretty well, but some of the top advantages are efficiency, both in terms of compression and in terms of energy usage, sound level, application versatility, and programmability and monitoring capabilities of the entire system. What are the cooling system requirements? That is maximum cooling water supply temperature, and is that included with the Q drive? Ideally, the Q drive would like to see water or coolant around 10 degrees C or 50 degrees F, but it can be much warmer, as high as 30 degrees C, 35, 33, 34 degrees C, 85 or 90 degrees F, depending on your specific application. Normally, if we have warmer cooling water, we do need to have a higher flow of coolant through the Q drive to remove that heat that's generated. Gas pressure ratio of 12:1 was discussed as an advantage of the design, although somebody's wondering how we can achieve that and maintain temperature control. They were looking at the screenshots that we were showing during the webinar, and it showed an inlet temperature of 70 and a discharge temperature of 332 with only a compression ratio of 4.36. How can we achieve 12:1? The Q drive does have cooling jackets around the gas sections, and we do have a heat exchanger between stages on multi-stage systems, and we do include a heat exchanger on the outlet. The Q drive, we can run with higher gas compression ratios by increasing the amount of coolant that's going through the Q drive to remove the heat, and it is regulated by the control. If we do get into a situation where it does start to overheat, it will slow down the Q drive to allow the heat to dissipate and keep it from overheating. What are the average lead times for these units currently? Standard units are running about 12 weeks. If you require special cleaning or other requirements, that can extend the lead time. Are there any application for refrigerant gases? Absolutely. We should be able to handle a variety of just about all refrigerants. Our standard materials, seal materials in there are Viton and ultra high molecular weight polyethylene. We can run different O-rings and seal materials if needed for your specific application. How far from the market is the hydrogen version of the Q drive? We're expecting to be ready to take orders towards the end of 2024, around the end of Q3 or early Q4. What is the lowest inlet pressure and the highest compression ratio capable for helium? What's the maximum temperature? The maximum inlet pressure is about 50 degrees PSI or 3.5 bar. Maximum compression ratio is around 12:1. And then the absolute maximum temperature inside the Q drive would be 380 F or 193 degrees C. As we approach that temperature, if the control senses that temperature anywhere in the Q drive, it will start to slow it down to allow it to cool off and not overheat. Why is the coolant piggyback not automatically included? And I assume we're asking about the chiller or a coolant system. And that's because many facilities already have cooling systems at their facilities, and they don't need another chiller, and they don't want to buy another one. So we make it as an option for the people that do need a chiller. Does Haskell or any of your reps or distributors have a unit good for 3,500 PSI outlet available as a rental unit for proof of concept or use for end users needing equipment every year or two? Generally, Haskell does not rent units. I do know that some of our channel partners have rented out some of our air-driven products in the past. Contact a Haskell salesperson or channels partner, and we can discuss your specific needs. There might be something we can do. We'll have to just discuss it and see if there's any way we can help you or work with you on that. We use 6 air compressors within our plant to maintain air at 150 PSI, while the other ones are maintaining air at 110 PSI. Would a Q drive be suitable for our application, or are they mainly used to achieve high pressure and not so much as air compressors? I'd love to sell you a Q drive, but if this is just compressed air and there's no purity requirements to be maintained in the air, a Q drive is probably overkill for your application. Again, happy to talk to you about it, but I have a feeling that your current compressors are probably might be, I won't say a better way to go, but I'm not sure with the Q drive. Other than the quietness, it may not bring you a whole lot that you're not, capability that you don't have from your current compressors. How far out do you think our hydrogen capacity capable Q drive is? Again, as I mentioned, it's 2024, towards the end of Q3 or early Q4. Will the unit be manufactured in CE, PED, ATEX versions? Current Q drives are already coming out with a CE mark and a PED mark on them. ATEX is not currently supplied. That will be on our hydrogen version of the Q drive. It will have the hydrogen version of the Q drive will have ATEX, EXE, EXD, I6 Zone 2, IEC 61511, and NFPA2. Again, that's on the future Q drive, not the current one. What is the range of the, excuse me, the inlet temperature? Minimum, I didn't say this here, but the minimum is about -40, and the maximum would be somewhere around 380 on the inlet or 193 degrees C. And that's the maximum temperature of the gas inside the unit. So we probably can't handle that high an inlet temperature of the gas directly. We are working on an application right now where they do have very warm gas. So we are adding a pre-cooler to the inlet line so the gas will be cooled off before it goes in and gets compressed. So that's always an option we can add to. Is there a minimum suction pressure? About 50 psi or 3.5 bar. Do you offer this unit as a portable unit? It can be mounted on a trailer, or since there's no real foundation requirements, it could be mounted on heavy-duty casters to be rolled around. It does weigh about 2,500 pounds, so I don't know what they mean by portable exactly. I mean, it doesn't have to be bolted to the ground on a foundation, so it does have limited portable operation capabilities, but I mean, it's not something that's real easily portable, though. Does it come with pulsation reduction devices? The standard Q drive does not include any outlet receiver or accumulator to reduce pulsation. In one pulsation sensitive application, we did update our software so it would, as it started to approach end of stroke, it would slow down. And then as it switched, as it switched over, then it would start compressing on the other side, and we'd have a very small pulsation coming out of it when we did that. That would only work on a single stage double acting unit. You wouldn't be able to do that with a two-stage unit, since you only have gas on a two-stage unit coming out when the motor goes in one direction. There on a two-stage unit, if you had concerns about pulsation, you would definitely want to use some type of a receiver on the outlet to absorb that pulsation. Does the Q drive need compressed air? Yes, some of the internal control valves are air operated, so we do need a source of compressed air to operate those valves. It could be nitrogen or other gases also for doing that. But yeah, we do have air operated valves inside the Q drive. Can the Q drive be used for CNG applications such as fueling? As mentioned previously, the current Q drive is not rated for combustible gases or use in hazardous environments. That'll be coming out towards the end of next year. What is the life of the servo motor? The servo motor is designed to have a life of at least 20,000 hours. What are the dimensions of the unit? Q drive is about 96 inches long, 37 inches deep, and 54 inches high with the doors closed. And as I mentioned previously, it has a weight of about 2,500 pounds. There's a little bit of plus or minus depending on the configuration, how many heat exchangers we have in there, and which gas sections we're using. Do you install on site and how long to do so? We do offer startup and assistance in commissioning. This normally takes a day or two. We would hope that the customer or a contractor would have the site ready to go, any foundations already in place, and the utilities all run over to that site, gas lines all in place. So all that has to be done is connect it up, put power to it, check phase, and the coolant's there, and the gases are connected up, and we should be ready to go. And it can be done very quickly in a day or two. Hi, will the entire webinar be available on YouTube, including questions and answers? Yes. By the fact that you're watching this right now, you can tell that it's on the YouTube channel. What about the maintenance regarding the servo motor? The main preventive maintenance for the servo motor is just changing the oil out every 2,000 hours and then replacing the motor itself at around 20,000 hours, or maybe a little bit longer than that, depending on your application. Will there be any UK distributors able to install and help set up? Haskell already has manufacturing, sales, and service office in the UK, and there are service people there trained in startup and commissioning of the Q drive, and we already have one Q drive working just fine in the UK. It's handling argon. What is the gas piston ring life? And I assume you mean our gas seals, and they are designed for at least 2,000 hours of life. What is the maximum cooling water supply temperature? I mentioned this earlier, but it's around, it's going to depend on your application, but around 85, 90 degrees Fahrenheit, 30, 32 degrees C. The warmer the water is or coolant is, the higher the flow rate we're going to need through the unit to remove the heat that's generated. And those are all the questions we had. So please reach out to Jobin or myself with any questions, a local channel partner, a local sales office. We'd love to answer your question, any additional questions you have, or talk to you about your applications. Thank you very much, and have a great day.